Good morning. I am Amit Kumar, Assistant Professor, Computer Science Department, Akgec Kumar Garg Engineering College, Ghaziabad. So, as we know that the subject name Software Project Management. So, today's topic is Network Analysis with CPM, Critical Path Method. So, outline of this topic is, at first we introduction about the project management, then what is network analysis in project planning, and what is role of the project plan network analysis in a project planning, different network techniques that are used in network analysis, and then we discuss one of them in critical path method, that is CPM, how to draw network diagram, and with an example we can conclude it and calculate the total scheduled time of each activity. As we know that a project is a critical part to handle by the manager. So, the overall responsibility of the manager to plan accordingly that the project is quality wise with minimum efforts and within a time frame. So, scheduling is a main important parameter to control or a monitor of a project, because of a manager has a bear a responsibility to complete a whole project within a given time frame or a given time schedule. So, project management is concerned about the planning, implementing, controlling and organizing. So, that is the role of manager to plan accordingly. Suppose that a project is X is a project and various activities involved in this project, or we can say that we further break in sub activities part of the project, and each part or activities are monitored by the manager. So, planning and implementing and monitoring and the organizing all the resources of the organization to complete some assignment, duties, tasks and event in intended timeline. So, intended timeline, that means within a given time frame. As a network analysis in a project management is help to the manager for what? For drive the better decision to help the ensuring a smooth project completion. So, when we talk about the triangle role of the project, that is time, quality and efforts. So, this one is the schedule. Time is very important part for the project completion. At first we know about what is network analysis. Network analysis is nothing. This is a technique that adopt the planning and controlling a unique and complex project. So, complex and unique projects are handled by the manager, and manager scheduled each activity within a time frame. So, we can say that this process is helpful to the different phases of a project manager for planning, controlling, coordinating to decision making. That means, suppose that we have a project X, and X have some A, B, C and D, activities. So each activities are completed within a time frame. It's the responsibility of the manager. So network analysis, through the network analysis, so visual representation method, we can draw a diagram and shows how much time taken by the each activities. So that is analysis, network analysis. So we have a different type of network analysis techniques to choose the right path as well as to complete a project within a given time schedule. So this one is a program evaluation and review technique, that is PERT, a very most popular PERT technique, and the critical operating production allocation control, COPA, and critical path method, that is CPM, least cost scheduling, LCS, resource allocation multi-project scheduling, RAMS, manpower allocation procedure, MAP, project control system, PCS, resource planning and scheduling method, RPSM, graphical evaluation review technique, that is GERT. So we have a different type of technique for the network scheduling. Here we cover only this CPM, critical path method. At first we draw a network diagram and then we find out a critical path and then find out the total time duration taken by a completion of the project. So with the help of example we can cover it. So at first we understand what is critical path, and so critical path management is a technique of a project management which is used to manage only time activity of any project. So certain, that is time, the activity of the project. The critical path method is the longest path through the network is called the critical path. So we choose, the manager choose a right path, correct path. For what? For its scheduling. Scheduling, that means when I am given an example, with the help of example you can better understand the things. The length of the minimum in which said the project can be completed. So this one is overall about the CPM. Critical path is a powerful technique used to planning, scheduling and managing the project. Project manager identify the most critical task and ensures efficient project completion. So critical path sequence activity of a project that start and finished, that takes the longest time of the completion, and that is, this one is a mathematical calculation for use for the scheduling project. Scheduling project, that means for the finding the time. The scheduling project, that means time framework, and that is given by or developed by the Well and Walker in 1950s. He worked on a building and maintaining chemical plants. So with the help of example we can understand what is a critical path, how can we draw a network diagram. So here an example, we have activities, predecessors and the duration in a month, and we find out the CPM analysis and identify a critical path of a project. So predecessors are also given after completion of the A, B activity is start. After completion of the A, C will start. But initially A have a no predecessors, that means the starting point of A activity. So this table or math table we can calculate the critical path, find out the critical path and calculate the total duration. So through this numerical we construct a network diagram, compute the earliest event time and largest event time, and find out the critical path and total duration time. So with the help of table we draw a network diagram. Please, a starting point is A. Suppose A is our start point. Because of A has no predecessors, then activity B, A take a 5-month duration for completion. So activity B and its predecessor is A. That means when A is finished, then B will be start. As the same C, when A is finished, then C will start. So with this method we can draw a network diagram. Then the D activity and the predecessor is B. Then the finalizing of the B activity we start D and its duration is 6 months. E activity after finalization of C. But here we see that the F activity have a 2 predecessors, D and E. That means when we finalize or finish the D and E activity, we will start F. And this is a final activity. After the finalizing the F activity, finish our project. So this one is a network diagram. So this have a 5-month duration, B activity have a 4-month duration, C activity have a 5-month duration, D activity have a 6-month duration, and E activity have a 3-month duration, F activity has a 4-month duration. So with the help of this network diagram, we find out the critical path. So this one is a network diagram. So at each activity level, we find earliest start, earliest finish, latest start, latest finish, and float value. With this diagram, we can conclude that earliest finish, duration that are given in our example. This one is the duration in a month. Then earliest finish, this activity level, activity that is A, B, C or D. Latest start, this one is the float value. Float value, that is we can say that the slight difference between the completion of the project and the estimation, and the latest finish. So the earliest finish is a date or a time which the activity can be start at the earliest. So this one initial, that one is a 0 initial. If we talk about the A activity, that means this one will 0. If we talk about the B activity, maybe this one is after completion of the A. Then the earliest finish is the date and time which is activity can be completed at the earliest. Latest start is the date or time which the activity can be started at the latest, and the latest finish is the date and time which the activity can be finished at the latest. And the float is equal to the difference between the earliest start and the latest start. This one is the difference between duration and finish time. So with the help of this table, we fill each and every values in each activity. So a same example, and earliest start, this D is duration, earliest finish, activity, latest start, this is the float value, and this one is the latest finish. So A is an activity, we construct in such a manner, that is A, then this one is a B, this is C, this one is D, E and F. So start with the A, because of A have no procedures, and duration time is 5. So we fill every A, B, C, D, E, F, each activity we fill the duration. So we filled 5, this one is the 4, then C have a 5, then D 6, E 3 and F 4. Each duration we fill separately with the given table, with the help of table. So this field is covered. Earliest start, we cover this field. Earliest start, that means initially the activity A is 0. So start from the 0, and it's take a 5-month duration. That means earliest finish is earliest start plus duration. So 0 plus 5, that means 5. The total time taken by the A activity is 5 months. When we start B, after finalizing the A activity, we start a B activity. B activity, that means its earliest start time is 5. And its total duration taken 4 months, then 5 plus 4 is equal to 9. So its the earliest finished value is 9. In the same manner, a C, after the completion of the A activity, we will start the C. Then the earliest start is 5, because of this 5 we taken, and the value of the duration of C is 5, then the 5 plus 5 is equal to 10. So earliest finish value of the C activity is 10. We conclude in a similar manner D, E and F. So we suppose D, earliest start is 9, because of earliest finish is 9 of a B, then this earliest start value is 9, and the duration of D activity is 6, then 9 plus 6 equal to 15. Earliest finish value of D activity is 15. Here E activity, earliest finish of a C activity is 10, then the earliest start activity of E is 10, total duration of E activity is 3 months, then 10 plus 3 is equal to 13. 13 is the earliest finished value of E activity. We see here, when we find out the earliest start value of the F activity, we have not conclude which value we take. But suppose that after finalizing the D as well as after finalizing the E, we will start F activity, then we find the maximum value of this value. So we see that the 13 and 15, the maximum value is 15, so we choose a 15. So 15 is our earliest start value of F activity, and its total duration is 4 months. Then the earliest finished value of F activity is 19. So this is known as forward pass. This procedure is known as forward pass. In a similar way, we can calculate backward pass, that can be calculated in a LF, latest finish and latest start. So start, latest finished value is equivalent to earliest. This 19 is a this one, because of earliest finish is 19, then latest finish is 19. So we can calculate the value of LS with the help of this formula. LS is equal to LF minus EF. Latest start is equal to latest finish minus duration. 19 minus 4. 19 minus 4, that means 15. This value is come from there. So with the help of this formula, we conclude the latest start. Then this latest start is a value of latest finish. So 15 is there, and 15 minus 6 is 9. 15 minus 6 is 9. In a similar way, the 15 value of E activities and 15 minus 3, that is 12. Earlier start, and we find out the slot level or a slot, and say that the float value. Float value we calculate latest finish minus earliest finish. Latest finish, that is 19, and earliest finish is 19, then 19 minus 19 is equal to 0. So in similar manner, we find out the difference between 15 and 13, that is 2. The float value is 2 here. 15 minus 2, the float value is 0. So accordingly, E and D, E activity and D activity, we find out the value of LS, SL and LF. And a B activity, this 9 is equivalent to this one, latest finish, and the difference between 9 and 4 is 5. That one is latest start of B activity, and a float value of B activity is equal to 9 minus 9, that is 0. In a similar way, this latest start is equivalent to latest finish of C activity. The difference between LS and duration, LF and duration of C activity, 12 minus 5 equivalent to 7 is LS with the help of this formula, and the float value of C equal to difference between 12 and 10 is equal to 2. We see here, we have 5 and 7 and 5, two values. The first one is 7 and second one is 5. So the value of latest finish of A activity is minimum value of C or B. So minimum, so 5 and 7, the minimum value is 5, therefore we choose 5 here. The difference between 5 and 5 is 0, and the float value is latest finish minus EF, that is 0. So with the this diagram, we can say that is network diagram, and we find out each value of earliest start, earliest finish, latest start, latest finish, and float value with the help of duration for each activity. Then we analyze that here we finalize the project in two ways: the A, B, D and F, or A to C, then C to E and E to B. There are two paths. So a manager choose the correct path, that schedule is minimum. That means where the float value is minimum, we choose that part. Here we see that the float value here the 0, but in this path, the second path, we have slightly changed the value of 2 and 2. The float value is 2. More, this one is not minimum accordingly the first path. So we have this path is choose because of its minimum value. So this is known as critical path. The manager are responsible for choosing this path. This is given a minimum time duration. So minimum time duration is A. We have two paths, A to B, B to D and D to F, A to C, C to E and E to F. So we choose this one. This is critical path, and the total time is taken by the project or of a completion 5, this duration, this one, plus 4 plus 6 plus this one is 4. So 9, 15 and 19 months. So 19 months is a total duration of this completion. This is known as, when we calculate upper part, earliest start, earliest finish, this is forward pass, and when we calculate the latest start and latest finish, that is backward pass. So with this calculation, we find out the critical path and total duration in a month of a given activity. So this do a CPM analysis and identify the critical path. So critical path is this one, the double line is there, and earliest values time and latest event times are, we calculate in this manner and find out critical path, and total duration time is 19. So manager choose the correct path for the activities for completion of the project. So with the help of this numerical, we can understand the critical path analysis within when the scheduled planning, network schedule planning by the manager. Thank you.